और भाई कैसे हो? तो आज वाला क्वेश्चन भी कर ही लेते हैं यार, अब कॉन्टेस्ट वॉन्टेस्ट हो गया तो ये भी कर लेते हैं। सो आज 83 दिन का स्ट्रिक कर दिया भाई आज मैंने। बहुत हो गया भाई अब तो क्वेश्चन है ये ये पता है, एक बार पहले भी ऐसा कुछ क्वेश्चन आया था जिसमें रिमूव कुछ कैरेक्टर्स था। सो लेट्स सी व्हाट डू गिवन a string s return the lexigraphically smallest subsequence of s, right? Lexigraphically smallest subsequence of s contains all distinct characters, right? There are two important things: smallest, second, smallest subsequence lexigraphically, okay, contains all distinct. Now, what does both points mean basically? Right, contains all distinct, it means subsequence means order, right? Order of elements should be preserved, right? All distinct means every distinct should appear, right? So for example, b c a b c, right? So what is the smallest, right? A, then b c, right? There are only three characters and all are there, right? So this is our answer. Okay, now how to do this thing, right? So first, can I can I find out frequency of each element, right? Frequency of each element, right? So we'll do, right, frequency of I, right? What is its size, right? 26, right? Alphabetical characters. Now now tell me one thing, right? So if I am at this index, right, B index, right, and I know another B can appear later, right? Another B can appear later, right? Okay, at C there's another C, right? And is this right? Is this C? Let's say I pick B, right? This is my new subsequence. Now, if is this C, right? The current C. Is this C greater than this previous one? Yes. So again, right, subsequence will become BC. Now tell me about this A, right? Is this A greater than this, right? No. It means this A should come here, right? So what I will do, I will check for each element, right? I will check for C. Does that C appears later? Right. See, if this appears later, then can I say, right, I can remove this one and it will definitely come again, right? So this is my B A now. Now again check A with B. Can my B appears later? Yes. So can I remove this B and can I write this as A, right? Now if I go ahead, I'll check B. Again it's greater, it's fine. Again it's greater, it's fine. So A, B, C is an answer. So what it is like, it's like a push, right? Greater elements to n, right? See, but if it's smaller and right, last character appears again, right? Remove that. So it's simply like like stack operations basically, right? What do we do? What are the cases that we know? Okay, case, right? We iterate over, right, current character, right? So we'll say s of I, right? If s of I, there is two things, right? One is stack, right? Or if presence in stack, right? Seen in stack and view of frequency. Now cases, right? Let's say if my s of I, right, is if my current character, right, greater than stack dot back, right? Whatever the stack dot top basically, not back, top. So what do we do? I add simply current character, right? Right? Do I do right? Stack dot push, right? Current character, right? And it's seen, right? Now it's seen. And why do we need seen? For uniqueness. Okay. Seen, right? We have seen as of I character basically. Okay. And we reduce its frequency. Frequency of s of I minus minus. Now, what is the case 2? If right s of I less than equals to right stack dot top. It means this my current character, right? Current character is smaller than what I have, right? That means it can be a new lexicographical string, right? Then what do I check, right? I will check, right? While stack dot top basically, right? Greater than what s of I and what it should appear again, right? So what I will check, right? Frequency of what stack dot top greater than 0, and it means it appear again, right? Right? If both of these things happen, then what do I do? I will do, right? Remove it from the stack. Okay. And what do I do? Is in stack? No. So I will say stack of s of I equals to false now. Right? So I'll do this operation, right, until it's, and in the end what I do? I'll again push the current element, right? See in stack, right? I will push the current element to stack, right? True, and we'll do stack, right? Stack dot push. We do current element, and in the end, right, our stack is our answer. Stack is our answer. Okay, so let's see the this part. Okay, so we've done a frequency. We keep a scene. We first calculates frequency, right? Frequency. Then what do? We check, right? String st. We'll use it for stack basically. Okay. If we decrease frequency, if it's already seen, discard, right? Already seen, we'll discard it, right? Otherwise, see, if string is not empty and this st dot back greater than c, and right again appears, and if it's again appears, right, just remove from stack. Remove, we make scene false. Okay, return the st. Time complexity is what? Of, and basically because pushing and popping out of stack is basically of 1 only, and this can be max of 26. So I it's like of and close 26 time complexity. Yeah, that's it. Thank you.